Running powerful artificial intelligence entirely on your own hardware means keeping your data private and your rules absolute. But there's an immediate bottleneck. Large language models are mathematically massive, built by default to span across enterprise-grade data centers. Take a look at this comparison chart. A standard 13 billion parameter model, uncompressed, requires about 52 gigabytes of memory. Compare that to the standard 16 gigabyte limit of a consumer laptop, or even the 24 gigabyte ceiling of a high-end desktop GPU. Try to load that baseline model at full precision on a home computer, and your system will simply crash out of memory. Local AI adoption stops dead right here, unless we can somehow drastically compress these models without lobotomizing them in the process. The industry's answer to this bottleneck is a process called quantization. Truncating a precise 32-bit floating point number to an 8-bit, then 4-bit integer reduces the model's complexity. As values lose trailing decimals, the file shrinks. But there's a tax. Every removed bit strips away a fraction of the AI's nuance and logical reasoning. This leaves you staring at a repository download page with 15 confusing versions of the exact same model: FP16, int8, Q4KM. Your goal is to find the exact mathematical sweet spot, the file small enough to prevent your computer from crashing, but precise enough to actually be useful. Let's start at the top end of the spectrum with formats like FP16 and Q80, which apply the least amount of compression. This matrix breaks down the trade-offs. Top row formats like Q80 yield 50% memory reduction, retaining 99% reasoning capability. But because files remain massive, this tier forces you to run a smaller 7 billion parameter base model instead of a 13 billion one. These files are built for AI researchers and data purists running ground truth benchmarks. For everyday local deployment, paying massive hardware costs for absolute mathematical precision is a poor trade. Now look at the middle of the spectrum, which is where the vast majority of consumer hardware actually operates. This is the domain of 4-bit and 5-bit formats, specifically the K quantization levels known as Q4KM and Q5KM. Returning to our matrix, watch the middle rows. Targeting Q4 and Q5 shrinks that massive 52 gigabyte model into an 8 gigabyte footprint, cutting hardware requirements by 85%. With vastly less data, inference speeds jump 3 to 4 times faster than the baseline. The tax for this compression is a measured 5 to 15% degradation in logic. In practice, your standard coding assistants and chat interactions remain sharp, though you might notice minor stumbles on highly complex multi-step logic chains. The Q4 and Q5 tier is the ultimate compromise for local machines, giving you immense speed and accessibility in exchange for an entirely acceptable loss of nuance. Then we reach the absolute bottom of the quantization matrix, stripping models down to 2 or 3 bits. This includes mobile-optimized formats like int8 and the extreme Q3 and Q2 levels. This tier provides maximum compression. The chart shows up to a 90% size reduction and a 5 times speed multiplier. But pushing the math this far triggers a devastating trade-off, a 15 to over 30% drop in AI quality. The compressed model loses its coherence, hallucinates frequently, and struggles to follow anything beyond the most basic instructions. In this split-screen output, a standard 4-bit model handles prompts cleanly, while a severely compressed 2-bit model falls apart into chaotic, error-ridden text. Extreme quantization is a survival mechanism for severely constrained hardware. It should never be your default choice on a capable desktop. Let's turn this complex mathematical theory into a practical roadmap so you know exactly which file you need to download. This flowchart is the Insight Anchor quantization matrix. It routes you to the correct format based entirely on your specific hardware. If you are an AI researcher demanding absolute fidelity for benchmarking, accept the hardware cost and select FP16 or Q8.0. If you are an engineer paying for cloud compute by the hour, Q5.km provides massive cost savings while keeping quality loss under 5%. If you are running AI on a personal Mac or consumer desktop GPU, Q4.km is the undisputed choice for everyday use. And if you are deploying to mobile devices or a Raspberry Pi, you need to stick with INT8 or Q4.ks to fit the physical limits of the chip. Matching your exact use case to this matrix eliminates the paralysis of the repository download page. Keep one golden rule in mind. Never over-quantize out of a preemptive fear of your hardware limits. Always download the Q5KM or Q4KM version first and test it against your own complex daily prompts. Only drop down to a Q3 or Q2 format if your machine physically crashes or stalls trying to run the 4-bit baseline. Quantization is the translation layer. It takes theoretical, data center locked intelligence and scales it down into a practical, secure tool that runs right on your desk.